In this video, I will teach you how to graph an exponential function like this one. Now, when we first begin, I only want you to look at the parent function, which is this part of the function. We will deal with the 3 and the 2 and the -1 later. So for right now, we really are just starting with the function y equals 1/2 to the x power. So what you do is you make yourself a table of values. Okay, x's and y's. And we're going to do 5 values. For the x values, we will do -2, -1, 0, 1, and 2. And for the y values, we will use this parent function. So let's start at the bottom, because that's always going to be easier. So looking at the bottom here, when we say 1/2 to the x power, that means we're talking about 1/2 squared and 1/2 to the 1 power and 1/2 to the 0 power. Okay, we're doing all of these powers. And then it would be 1/2 to the -1 power and 1/2 to the -2 power. And that's how we will get our y values. Well, 1/2 squared is just 1/4. 1/2 to the 1 power is just 1/2. Anything to the 0 power is 1. And let me teach you the shortcut first. These last two values are going to be the reciprocal of the bottom two values. So the reciprocal of 1/2 is 2, and the reciprocal of 1/4 is 4. Now, just for example, look at the 1/2 to the -2 power. Understand that when you have a fraction to a negative power, you can do the reciprocal, and then it will be a positive power. So that will give you 4. All right, so you could do this directly, but if you already have the bottom two numbers, it's just so much quicker just to do the reciprocal. Anyway, so we have our table of values now. Here's the next thing you do. Now we will look back and see if we need to make a new y column or a new x column. Now, the only thing I'm going to make a new y column or a new x column for is if there's something that's being multiplied, if there's a vertical stretch or compression, or if there's a horizontal stretch or compression. I'm not going to do anything with the +2 and -1 yet. But because of the 3, because of this, I'm going to make a new y column. Okay, so I'm going to have a new y column, so I'm going to just stretch these lines out like this. All right, and my new y column will be 3 times the old y column because of the 3. So this will be 12 and 6 and 3. Half of 3 is 1.5. 3 times 1/4 is 3/4, which is 0.75. Okay, so we have a new y column, so I can throw out the old y column. So I'm going to plot these points right now. Okay, so I've got -2, 12. All right, so -2, 12 would be right here. And I've got -1, 6. So that's going to be right here. 0, 3 is going to be right here. 1, 1.5 is going to be right here. And then 2, 0.75 is going to be right here. Okay, now I will not connect these dots because this is not the final answer. What I haven't done yet is I haven't done my horizontal and vertical translations. This +2 right here means actually left 2. The -1 right here means that the graph will be shifted down 1. So I need to move everything left 2 and down 1. Okay, and look, while I'm at it, the parent function has a horizontal asymptote at 0. All right, the x-axis is the asymptote of the parent function that I've graphed with the blue dots. However, because the graph is moved down 1, my new horizontal asymptote will be at -1. So I'm going to have a new asymptote that's here. So I'm going to go ahead and draw my new asymptote as a dotted line. Okay, so there's the new asymptote. So now I'm going to go back and I'm going to move every dot left 2 and down 1. Okay, so left 2 down 1, left 2 down 1, left 2 down 1, okay, left 2 down 1, and left 2 down 1. All right, so these red dots represent my final answer. So your graph should look something like this. I apologize for how jagged this looks, but this is actually really tough to do with the digital pen that I'm using. All right, that's it. That's how you graph an exponential function. Let's do another example. So again, I want you to start off just looking at the parent function, y equals 2 to the x power. So let's make a table of values just for that. All right, and I'm always going to use the same x values, -2, -1, 0, 1, and 2. Now remember, for the y values, I'm doing 2 to the x power. So that means I'm doing 2 to the -2 power, 2 to the -1 power, 2 to the 0 power, 2 to the 1 power, and 2 squared. I recommend starting from the bottom and moving up. 2 squared is 4, 2 to the 1 power is 2, anything to the 0 power is 1, and these two should be the reciprocals of these two. So it should be 1/2 and 1/4. Okay, see how easy that is? So we have our table of values. Now we will move on, and if there is an a value, if there's a number in front, a vertical stretch or a vertical compression, we will make a new y column. So we do need to do that. So we're going to make a new y column. Okay, and the new y column will be 3y because of this 3. So 3 times 1/4 is 3/4, all right, which is 0.75. Half of 3 is 1.5. And then 3 times 1 is 3, 3 times 2 is 6, 3 times 4 is 12. So I have a new y column, so I can throw out the old y column. I am not going to do anything with the +2 and the +1 yet. I will do that on the graph itself. So let's go ahead and graph these. Okay, dots only, do not connect these because this is not the final answer. But I have -2, comma, 0.75. So -2 and 0.75 is about there. I've got -1 and 1.5 would be here. 0, 3 is right there. 1, 6 is right here. And 2, 12 is right here. Now this is not the final answer because I have not done anything with the +2 and the -1 yet. Okay, this +2 means we are going left 2. Okay, it's always, the left-right number is always the opposite of what it looks like. This +1 means we're going up 1. By the way, that up 1 is going to change the horizontal asymptote, which starts at 0, but because we're going up 1, the new horizontal asymptote should be at 1. So this will be my new horizontal asymptote. So let's draw that as a dotted line. Okay, so I'm going to take all of my dots and move them left 2, up 1. Okay, so left 2, up 1, left 2, up 1, left 2, up 1, okay, left 2, up 1, and left 2, up 1. All right, so these red dots represent my actual final answer. Okay, so your final graph should look something like this. All right, mine always gets a little jagged at the end, but I'm doing the best I can. So that's it for problem number 2. Let's do 2 more examples. Again, start by simply making a table of values for the parent function y equals 4 to the x power. So that's going to look like this. And I will always start with the same value, x values, -2, -1, 0, 1, and 2. For the y values, I'm doing y equals 4 to the x power. So that means I'm doing 4 to the -2 power, 4 to the -1 power, 4 to the 0 power, 4 to the 1 power, and 4 squared. Well, 4 squared is 16. 4 to the 1 power is 4. Anything to the 0 power is 1. And these two should be the reciprocals of these two. So this will be 1/4 and 1/16. All right, so that is how I start off my table. Now, if there is an a value, all right, a number in the front, I need to make a new y column. So I do need to make a new y column. And my new y column will be 1/4 times the old y values. Okay, 1/4 times 1/16. So that's 1/64. 1/4 times 1/4 is 1/16. 1/4 times 1 is 1/4. 1/4 times 4 is 1. And 1/4 times 16 is 4. So these are my new y values. So let's go ahead and plot these points, even though they do not represent the final answer. So -2, 1/64. 1/64 is so small that it's going to appear to be just like 0 would be. All right, but just in your mind, know that it's not quite touching the line in reality. -1, 1/16. All right, it's still so small that it's really just going to appear to be on the line. Okay, 0, 1/4. All right, so that's just 1/4 of a unit up. So it just begins to lift up off of the axis now. And then 1, 1. All right, starting to get into normal points now. And then 2, 4 would be right here. Okay, now, what we haven't done yet, and the reason why we are not connecting those dots, is we still need to do the horizontal and vertical transformations. This +1 means that we are going left 1. This +2 means that we will move everything up 2. The up 2 will affect the horizontal asymptote, which normally would be the x-axis, but now it's going to be up 2. So my new horizontal asymptote is here at 2. All right, for the rest of these points, I'm going to move them left 1, up 2. Okay, so left 1, up 2. Left 1, up 2. Okay, left 1, up 2. All right, left 1, up 2. All right, so these red dots represent the actual final answer. So I'm just going to try to draw a smooth curve through that. All right, so your final answer should look something like this. All right, let's do one more example. Again, the first thing we will do is we'll make a table of values just for the parent function, y equals 6 to the x power. Okay, and for the x values, we will do -2, -1, 0, 1, and 2. For the y values, we will be doing 6 to the x power. So that will be 6 to the -2 power, 6 to the -1 power, 6 to the 0 power, 6 to the 1 power, and 6 squared. Well, start from the bottom and go up. So this is going to be 36. And this is going to be 6, and anything to the 0 power is 1, and then this will be 1/6, and this will be 1/36. Okay, so that's my table of values. Now, if there is an a value, which in this case is 1/3, you need to make a new y column. So that's what I'm going to do, make a new y column. And my new y column will be 1/3 times all the y values. And these are the new y values. 1/3 times 1/36 is 1/108th. 1/3 times 1/6 is 1/18th. You just multiply straight across. 1 times 1/3 is 1/3. 6 times 1/3. That's the same thing as 6 divided by 3. So that's 2. 36 times 1/3 is the same thing as 36 divided by 3. So that's 12. So these are my new y values, so I can really throw out the old y values. So I'm going to plot these points, but I will not connect the dots because this is not my final answer. Now, -2, 1/108th. That is so close to 0 as it will appear to be on the line. And really the same thing with -1 and 1/18th. 1/18th is so small that it's just going to appear to be on the line. The 0, 1/3, all right, that's 1/3 of a square up, so that'll begin to lift off the x-axis. Then 1, 2 is starting to take off, and then 2, 12 jumps way up there. 2, 12. Now that is not the final answer because we have not done the horizontal and vertical translations yet. This +2 means that we are going to go to the left 2, and this +1 means that we are going to move everything up 1. Now that up 1 is going to also affect the horizontal asymptote, which starts off at the x-axis, but if I move it up 1, this is my new horizontal asymptote. Okay, so now I will move each of the dots that I just graphed left 2 and up 1. All right, so left 2, up 1, left 2, up 1, left 2, up 1, okay, and then boom and boom. So these red dots represent the final answer. So your final answer should look something like this. All right, so that is it for number 4, and that's how you graph an exponential function. The first thing you want to do is look at the parent function, 2 to the x power, y equals 2 to the x power. Let's make a table of values just for that. Let's use the x values -2, -1, 0, 1, and 2. Now, y is equal to 2 to the x power, because we're just doing the parent function. That means we're doing 2 to the -2 power, 2 to the -1 power, 2 to the 0 power, 2 to the 1 power, and 2 to the 2nd power. Start from the bottom and work your way up. 2 squared is 4. 2 to the 1 power is just 2. Anything to the 0 power is 1. These next two entries will be the reciprocals of these. So I'm going to have 1/2 and I'm going to have 1/4. Okay, so these are the points of the parent function. If there is a number in the front, an a value, we're going to need a new y column. So we do have this a value of -2, so we are going to need a new y column. And our new y column will be the a value times all the y values. So, -2 times 1/4, that's going to be -1/2. Half of -2 is -1. 1 times -2 is -2. -2 times +2 is -4. 4 times -2 is -8. So these are the new y values. So we can throw out the old y values. So let's go ahead and plot these points, but we will not connect them because they do not represent the final answer. So we have -2, -1/2. So that's going to be right here. And then we have -1, -1, 0, -2, 1, -4, and 2, -8. Now, we are not connecting these because they are not the final answer, because we have not done our horizontal and vertical translation yet. This +1 means the graph should move to the left 1. And this +1 means the graph should move up 1. This up 1 is also going to affect the horizontal asymptote, which normally would be the x-axis. But since we're moving everything up 1, I will have a new horizontal asymptote at 0. Okay, so draw that. So now I'm going to move each one of these points left 1 and up 1. Okay, so left 1 and up 1, left 1, up 1, left 1, up 1, left 1, up 1, and left 1, up 1. All right, it's very useful to do these in two different colors. So you can see in here, if these were all one color, it'd be really hard to see what I'm doing. Anyway, these red dots represent the final answer, so I'm going to go ahead and draw a curve through here. Okay, so your final answer should look something like this for number 5. All right, let's do one more example of that before we move on to writing equations given graphs. Okay, again, we will start by graphing, well, making a table of values just for the parent function, y equals 1/2 to the x power. So let's make a table of values just for that. Okay, so the x values, as always, we will use -2, -1, 0, 1, and 2. And y is equal to 1/2 to the x power. So I'm talking about 1/2 to the -2 power, 1/2 to the -1 power, 1/2 to the 0 power, 1/2 to the 1 power, and 1/2 squared. Start from the bottom. 1/2 squared is 1/4. 1/2 to the 1 power is just 1/2. Doesn't change anything. Anything to the 0 power is 1. The next two should be the reciprocals of the last two. So this will be 2 and 4. So there's our table of values for the parent function. If there's an a value, we will need a new y column. And this problem has an a value of -2. So that tells us that we will need a new y column. Okay, -2y. So multiply all these times -2. So this will be -8 and -4 and -2 and -1 and -1/2. So these are the new y values, so we can throw out the old. Let's go ahead and plot these points, but we will not connect these dots because they are not the final answer. -2, -8 will be right here. -1, -4 is here. 0, -2 is right here. 1, -1, and 2, -1/2 is right here. We are not connecting these, and these are not the final answer, because we have not done our horizontal and vertical translation yet. This -1 means that the graph will be shifted to the right by 1. The left-right motion is always the opposite of the way it looks. This -1 means that everything should be shifted down by 1, including the horizontal asymptote, which normally would be at the x-axis, y equals 0, but it will be shifted down 1. So the new horizontal asymptote we will draw as a dotted line down 1 and -1. For the rest of these points, we will shift each of the blue dots that we already graphed right 1 and down 1. So if I go right 1 and down 1, that's here. Okay, right 1, down 1, right 1, down 1, right 1, down 1, and right 1, down 1. These red dots represent the final answer, so I will just try to draw a curve through these. So your final answer for number 6 should look something like this. All right, so that's how you graph an exponential function. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.